Welcome, and this video is optional, and it's going to look at quadratic functions and looking at optimization problems with quadratic functions. And when I use the word optimization, all this means is finding a min or a maximum value, okay, based on a quadratic function. Okay, so we're just going to look at this example, kind of dissect it as we go through to help us figure out what we actually need to do. Okay, so we're looking at all rectangles that have a perimeter of 20. Find the dimensions of one whose area is largest. So, well, okay, this is where we need to maybe think a little bit. And so, rectangles, here's a rectangle. Okay, we know they have all right angles. That's not really that important. But then we remember that opposite sides have the same length, right? So, x, x, and y, y. Okay, and then from here we know what it says, that the perimeter is 20. So then this means that we have the equation 2x plus 2y is equal to 20. Okay, and it says I want to find the dimension of the one whose area is largest. Well, the area is x times y, right? Now, to do this, how do we proceed? We have two equations and we have seemingly three things that we don't know. Well, this is the quantity that I want to find max or min of. Okay, so what I'm going to do is I want to leave that, but then I want to simplify the variables. So I only want either x or y. Okay, and then if I want to find largest, that's going to be looking for a maximum value, right? So, okay, I'm looking for a maximum. How can I use this information? Well, really what we're going to do is take this kind of our auxiliary equation, okay, and use it to reduce the number of variables. So what we want to do is solve for y, and then when we solve for y, so let's just do that, y is equal to, okay, subtract 2x, divide everything by 2, I get 10 minus x. Then what I end up doing is taking y and substituting it in. Okay, so let's just kind of pause here for a moment and see what we've done. First, I'm going to draw picture. Second, write equations. That's kind of what I did after that. Third, I wanted to solve auxiliary equation for one variable and sub in to main equation. Okay, and this one, just to help us identify auxiliary versus main has the quantity that you want to find the min or max of, right? So here in the problem it said the area that is largest, so that is indicating we want to find the maximum area. Okay, alright, so I think I need to finish subbing in, so x and then 10 minus x. Okay, so this is going to be a is equal to 10x minus x squared. Okay, and then fourth, now this is a quadratic equation, and all I want to do is find the vertex. Find vertex. And if I do that here, so x is going to equal, oops, go back. So here we have a is minus 1, b is 10, so then x is going to be negative 10 over 2 times negative 1, which is 5. Okay, so that means x is 5, and then if I substitute in for y, okay, so that means, okay, so, and remember that y up from above was 10 minus x. Okay, there we go. Alright, so then that means that y is also going to be 5. Okay, in other words, it's going to be a square. But now, So I'm just going to say max dimensions are 5 by 5. Okay, so that completes the problem, but let's kind of review what we did. We drew a picture, we wrote an equation out, we solved the auxiliary equation, so the one that we're not finding, that isn't associated to a maximum or minimum value, solve it for one, substituted it into the main one, and then really what we were doing here was we found the vertex. Okay, and then lastly, we just wanted to answer the question. Which is what I did at the end here. Okay, and generally when we approach optimization or problems associated with minimum maximums, this is the sort of process that we go through. Now, the only thing that I will caveat this with is this problem did not ask for the maximum area. It didn't ask you what is the maximum area. If we wanted to say that, we could say max area is, and then remember this is just our area formula, so I would say A is equal to 10 times 5 minus 5 squared, which is 25. Okay, 50 minus 25. There we go. All right, so that's an overview of what optimization problems are like. Now, again, 4.2b on Hawks is optional, and if you complete it, I will replace one of your uncompleted Hawks assignments with a 1. So, in essence, do this one, achieve certify, you get another score that you didn't complete or that you didn't achieve certify on, raised to certify. All right, so we'll see you in class soon.